Guys, this is the second session on exercise number 7 of limits. 24 sub question 1. Okay. Limit x approaching 0. Cot x minus cosec x upon x. Okay. Converted into sin and cos. Cos x upon sin x. 1 upon sin x divided by x. Okay. So this will be cos x minus 1 upon sin x divided by x. Now this cos x minus 1, I'll reverse it. The purpose of reversing this is I'll get 1 minus cos x and then I can apply the formula of 1 minus cos 2x. Okay. So to reverse this, I'll just take minus sign outside. Limit x approaching 0, minus sign outside, 1 minus cos x upon sin x into 1 upon x. Okay. This x went down. So I reverse this by taking minus sign outside. A minus b can be written as minus of b minus a. Minus of b minus a. Okay. So limit x approaching 0 minus of 2 sin square x by 2 upon sin x into 1 by x. Okay. See, 1 minus cos 2x is 2 sin square x. So 1 minus cos x will be 2 sin square x by 2. Okay. So limit x approaching 0 minus 2 sin x by 2 into sin x by 2. 2 times we'll write sin x upon x. Now this sign has an angle x by 2. So beneath this sign, I'll just write x by 2 and multiply by x by 2. The next sign, this sign has an angle x by 2. So for this also I'll divide by x by 2 and multiply by x by 2. This sign, angle is x. So down x, I'll just divide and then multiply with x as well. So limit x approaching 0 minus 2 sin x by 2 into x by 2 sin x by 2 down x by 2 top x by 2 sin x upon x into x, and there is one more x over here. Okay. So this and this, the orange colored circles are 1. Okay. One of the x will get cancelled. Fine. This 2 and this 2 will get cancelled. So look at the terms now. Minus 1, this is 1. Into 1, this is 1. This x is left. Now this x can also get cancelled. It will get cancelled with the x which is down. This x and this x is gone. So we are left with half over there. And down, this is 1. So the answer is minus half. As x approaches 0, x by 2 also approaches 0, because we are applying the formula for x by 2 also. Okay. And this has to be 0. Let's go to the next question. That is question number 25. Okay. Limit x approaching 0. Sin 1 plus x minus sin 1 minus x upon x. This is c and this is d. Sin c minus sin d. Sin minus sin 2 cos sin. Okay. So c plus d upon 2. C minus d upon 2. There will be sign change for this term. So 1 minus x. So it will be minus 1 plus x upon x. So this is going to be limit x approaching 0. 2 cos x is gone. So this is cos 2, because 2 upon 2 is, okay, 1 plus 1 is 2. 2 upon 2 is 1. So this will be 2 cos 1. Fine. And here 1 and 1 is gone. 2x upon 2 is x. So sin x, and this x will be assigned to this sign. So this will be 1, and these are constants. Limit of a constant is constant, so 2 cos 1. Okay. Question number 26. Limit x approaching 0, root 2 minus root of 1 plus cos x, sin square x, limit x approaching 0. So root minus root is there. So that I'm going to rationalize. I'll just rationalize that. Okay. Limit x approaching 0, a minus b into a plus b, a square minus b square upon sin square x root 2 plus root of 1 plus cos x. So root 2 the whole square is 2. Okay. Minus this root is also gone. But then when you take this minus sign inside, 1 and cos will be negative. So limit x approaching 0, 2 minus 1 minus cos x upon sin square x into root 2 plus root of 1 plus cos x. Limit x approaching 0, 1 minus cos x sin square x root of 1 plus cos x. Now again, like the previous problem, I'll just make this half angle 2 sin square x by 2 upon sin square x root 2 plus root of 1 plus cos x. Now see, in the previous problem, the numerator had a square, but then denominator did not have a square. Here we are having square for both. So we can just group the squares, it will be more easy. So limit x approaching 0, 2 sin x by 2 upon x the whole square. Okay. 1 upon root 2 root of 1 plus cos x. Limit x approaching 0, 2 divided by x by 2 multiplied by x by 2 within the square, and down also divide by x multiply by x. So this x is getting cancelled. This and this will be 1. And here it will be root 2 plus root of 1 plus cos x. Okay. Now we'll put the value of x as 0 over here because it will not create a negative impact. It will not make the entire denominator 0. Okay. So what we are left with? We are left with this 2, that I'll write it over here. 2, 1 and 1 because we applied the formula. This will be 1 and this will be 1. Then half is left over here. Half square 1 upon root 2, 1 plus cos 0. Okay, so 2 into 1 by 4 into 1 upon root 2 plus cos 0 is 1. So 1 plus 1 is root 2. So 1 by 2 into 2 root 2. This is 2 root 2, so this will be 1 by 4 root 2. Let's go to the next problem. Question number 27. So question 1. Limit x approaching 0, x square minus tan 2x upon tan x. Okay, and by the way, in the previous problem, when you apply this formula, you have to write this up as x approaches 0, x by 2 also approaches 0. Okay, yeah. So limit x approaches 0, x square minus tan 2x upon 2x into 2x, because the formula is for tan and sine. Down also divide by x multiply with x. So this two encircled part or highlighted part will be 1. But then prior to that, when you, before making it 1, take one x common over here. Okay, we'll take one x common because that will cancel out the x which is there in the denominator. And why we have to cancel this x in the denominator? Otherwise, when you put x as 0 over here, it will be not defined. So we have to manage that first. So x minus 2 tan 2x by 2x, okay, upon tan x upon x into x. Now cancel out that x. So this x and this x is gone. Now we can put the values of the certain things over here. So x is 0, 2 into 1, this will be 1, and down it is 1. So the answer is minus 2. The note which you're going to write is, as x approaches 0, 2x also approaches 0. 2x also approaches 0. Okay. Let's go to 27 sub question 2. Limit x approaches 0, 4 sin x minus 9x cos x, 3x square minus 5 tan x. X approaches 0, 4 sin x upon x into x. Okay. Tan x upon x into x. Now we can take certain things common, some things common in the numerator. So this x is common. In the denominator also one of the x is common. Limit x approaching 0. So x 4 sin x upon x minus 9 cos x upon, take x common in the denominator, 3x minus 5 tan x upon x. This and this is gone. Okay. This circles will be 1, right? Because we can apply the formula directly over there. So this is equal to 4 into 1. This is 1 minus 9 cos 0. We can put 0 over here. Okay. And one more place we have to put 0 is this here. Because when we put 0 over here, it does not make a negative impact. It is not making the entire denominator 0. So this x and this green colored terms will be made 0. Okay. So 4 into 1 minus 9 cos 0 upon 3 into 0 minus 5 into 1. So 4 minus 9 into 1 upon minus 5. So if you solve this, you'll get 1. Fine. Next problem. 28 sub question 1. Limit x approaching pi by 4. Now see, it's not approaching 0. It's approaching pi by 4. Okay. Now sec square x is 1 plus tan square x. Okay. Fundamental identity. Limit x approaching pi by 4. So tan square x minus 1 upon tan x minus 1. Okay, 1 minus 2 is minus 1. So this tan square x minus 1 is a square minus b square. A minus b into a plus b. Limit x approaching pi by 4. Tan x plus 1. Tan x minus 1 upon tan x minus 1. This and this got cancelled. X is pi by 4. Pi by 4 is 45 degrees. Plus 1. So 1 plus 1 is 2. Okay. One last problem. Question number 28. Sub question 2. limit x approaching towards pi 1 plus cos cube x sine square x. Now this is sine, but then I'll not multiply and divide with x, something like that, because x is not approaching 0. So I'll have to do something else. So limit x approaching pi 1 cube plus cos x the whole cube. Okay, a cube plus b cube formula I'm going to apply. And down it will be 1 minus cos square x. So limit x approaching towards pi a cube plus b cube. So a plus b, a square minus ab plus b square. And down it is going to be 1 plus cos x, a square minus b square, and 1 minus cos x. So you're going to cancel out these terms. Now you put the value of x as pi. Pi is 180. So cos x is cos pi. Cos pi is cos 180. Cos 180 is minus 1. Okay, so if you put the value of x as pi over here, the denominator is not turning out to be 0. The denominator will be 2. So this all values you have to put. Okay, you put the value of x as pi, and after substitution you can simplify. Cos 180 value will be given to you directly by the calculator, so you did not remember it as well. Okay, now there is one question in exercise number 8, in exercise number 8, and that is question number 9. It is of the similar category, so I'll just explain this. Limit x approaching towards pi 1 plus sec cube x upon tan square x. X is not approaching 0, just remember that. So 1 cube plus sec x the whole cube, 1 cube plus sec x the whole cube, 1 plus tan square x. Sorry, this will be sec square x minus 1. Tan square x is sec square x minus 1. So limit x approaching pi a cube plus b cube, a plus b, a square minus ab plus b square, and this will be sec x plus 1 sec x minus 1. So this and this is gone. Okay, now see, let's understand this. Sec pi is equal to sec 180, which is equal to 1 upon cos 180, and cos 180 is minus 1, so sec pi is also minus 1. So this value is minus 1. You can put these values and complete the problem. Okay, let's go to question number 12 of the 8th exercise. Okay, question number 12, sub question 1, limit x approaching 0, x cos 1 upon x. Now guys, cos 1 upon x, cos of any angle lies between minus 1 to 1. So this value always lies between minus 1 to 1. Okay, and there is no denominator for this problem. So this x, make it 0, and this value will always lie between minus 1 to 1. So 0 into minus 1 to 1, between any value between minus 1 to 1 into 0 is 0. Okay. Similarly, the next problem, question number 12, sub question 2, x square, limit x approaching 0, x square sine 1 upon x. Okay. Now you can put the value of x as 0 for x square, and sine of any angle will lie between minus 1 to 1. So 0 into this particular value is 0. That's how we complete question number 12 of exercise 8. Okay, one last problem I'll do right now, and that is question number 10, sub question 2 of exercise number 8. Okay, so some problems of exercise number 8 also I have covered up. So limit x approaching towards pi sine 3x upon sine x. Now divide by 3x, multiply by 3x, divide by x, multiply by x. Those things I will not do because x is not approaching 0. So we'll have to do something else. Triple angle formula. Okay. So limit x approaching pi, take sin x common. So it will be 3 minus 4 sine square x. Now what you can do is you can cancel out the sign. Now you can put the value of x as pi over here. So sine pi is sine 180 and sine 180 is 0. So this value will be 0 square. Okay. So it is not making the denominator 0 because denominator is as it is 1. So this was a relatively simple problem. So sine 180, you can put the value of x as pi. Okay, but then after cancellation, after cancellation. So 3 minus 4 into 0 square. That will be your answer. Okay, thank you. मैं थोड़ा wait wrap up कर देता हूँ मैं How are you? Good.